Okay, so now we're going to look at example 2 from the balancing redox equations practice sheet. And number 2 is a little bit more difficult than number 1 because if you notice, number 2 has oxygens in it, where number 1 was just Ce and Sn. So just like we did before, you want to make sure that you assign oxidation numbers before you do anything else. So if I assign oxidation numbers to everything in this reaction, remember that oxygen is always -2 unless it's with fluorine. So if each of these oxygens is -2, that's going to give overall a -8, that's a minus. And MnO4 has to equal -1. So if oxygen, all the oxygens are -8, that means that Mn must be +7. Now, C and N is a little bit more difficult. So when you're not sure, the more electronegative atom is the one that's always going to be negative. So that means that nitrogen will be -3, and cyanide has to equal -1. So if nitrogen is -3, that means that carbon must be +2. So that's looking at permanganate and cyanide. Now we're going to look at MnO2. So just like before, each oxygen is always -2, which means that Mn, since there's no charge, this must equal 0. So if each oxygen is -2, that whole thing is -4, which means Mn must be +4. Now, C, N, and O, again, is a little bit more difficult. So remember that oxygen always must be -2. Now between carbon and nitrogen, the more electronegative one is going to be the one that is more negative. So nitrogen is more electronegative than carbon, so nitrogen will carry the -3 charge, which means then we need to figure out what carbon would be. CNO has to have a total charge of -1. So if N is -3, O is -2, that's -5. That means that carbon must be +4. So now that we have our oxidation numbers figured out, we need to look at what is the oxidation half reaction and what is the reduction half reaction. So if we're looking, we have Mn going from +7 to +4. So I know that MnO4 minus going to MnO2 is half of the reaction. So one of the half reactions is MnO4 minus becoming MnO2, which means that Cn minus going to CnO minus is the other half reaction. So Cn minus going to CnO minus. Now if we think about each of these, let's label whether it's oxidation or reduction. So if Mn is going from +7 to +4, that means that the oxidation number is going down. So this is the reduction half reaction. And then carbon is going from +2 to +4. So its oxidation number is increasing, which means it's losing electrons. So this is the oxidation half reaction. So now we're going to work through all of these steps for balancing redox. So since we do have oxidation reduction, since the oxidation numbers are changing, we have to balance it using the half reaction method. So we've written the equations for the oxidation half reaction and the reduction half reaction. So now for each half reaction, we're going to go through each of these balancing steps. So let's start with balancing everything except for hydrogen and oxygen. So for the reduction half reaction, I have 1 Mn, 1 Mn, so that's good. Then in the other half reaction, I have 1 carbon, 1 carbon, 1 nitrogen, 1 nitrogen, so that's good. Then we have to balance the oxygen. Make sure that you're doing it in this order. So I'm going to balance the oxygen using water. So in the reduction half reaction, I have 4 oxygens and 2 oxygens. So that means I need 2 more oxygens on this side. But I'm not just going to add O, I have to do it using water. So if I needed 2 more oxygens on this side, I'm going to add 2 waters. If I look at the oxidation half reaction, I have Cn minus, CnO minus. I have no oxygens on the left, 1 on the right. So I'm going to add 1 water. Then we balance the hydrogens using H+. And so if I look up here, I have no hydrogens on the left and I have 4 hydrogens on the right, which means I need another 4 hydrogens on the left. So I'm going to balance that using H+. So I have 4 H+, and I have 4 hydrogens. Looking at the oxidation half reaction, I have 2 hydrogens I have none on this side, so I'm going to add 2H plus to the right. So once all of the atoms are balanced, then we're going to balance charge. So when you're balancing charge, you're looking at the total charge on the left, the total charge on the right. So on the left, in this reduction half reaction, I have +4 minus 1. So this entire side, just put it up here, is +3. This entire side is 0. I need to make them equal. So to make them equal, you have to add electrons. Remember, electrons are negative, so I'm going to add it to the more positive side. So if I want these to equal 0, I need 3 electrons here because 3 minus plus 3 is 0. Then I'm going to look at the oxidation half reaction. So I have -1 total on the left. I have -1 plus 2, that's +1 on the right. So this is -1, this is +1. I need them to equal the more negative charge. So I need both of them to equal -1. So I'm going to add 2 electrons to the right. Notice how every time I'm adding electrons, I'm always adding them to opposite sides. You always need to make sure that your electrons cancel. If your electrons aren't canceling, something went wrong. So make sure that they're getting added to the opposite sides. And then the next step is to make sure that they equal. So I have 3 electrons in the reduction half reaction and 2 electrons in the oxidation half reaction. So I need to get those to equal. So what can I get those to equal? What can I multiply by? Well, I can get this to equal 6 and this to equal 6. So to do that, I'm going to multiply the entire reduction half reaction by 2 and the entire oxidation half reaction by 3. So I'm going to rewrite that down here. So I'm going to have 6 electrons plus 8 H plus 2 MnO4 minus yields 2 MnO2 plus 4 H2O. And then if I look at the oxidation half reaction, I'm going to have 3 H2O plus 3 Cn minus yields 3 CnO minus plus 6H plus 6 electrons. So now your electrons should equal. So when I add these together, anything that is on the left and the right can cancel. And it doesn't have to be everything that cancels either. So if you notice, 6 electrons will cancel. But I also will have some H plus canceling. I have 6 here, 8 here. If I cancel 6 of them out, it leaves me with 2. I have 4 waters here, 3 waters here. So if I cancel out 3 of the waters, that leaves me with 1. So now when you add everything together after you've canceled, that's going to be your new balanced redox reaction. So I'll write this out, 2H plus 2 MnO4 minus plus 3 Cn minus yields 2 MnO2 plus H2O plus 3 CnO minus. There we go. So here is my balanced redox reaction. And then again, you can double check, make sure you have equal number of H's, Mn's, oxygens, make sure that your charges are balanced. And once you do that, then that's your answer.